ladies and gentlemen, colleagues, doctoral candidates, students. It's a great pleasure and honor for me to welcome you to today is the 14th International Excellence Talk of Karlsruhe Institute of Technology, and we have established this monthly lecture to provide, let me say, a platform to discuss current research topics on internationally renowned scientists in an interdisciplinary context. And that is also why we have at KIT established the so-called International Excellence Grants and Fellowships Program, which makes it possible for researchers at KIT to invite outstanding international colleagues to perform joint research. And at this point, many thanks to my colleagues from Intel, who have organized and managed the program, especially Mrs. Pfeiffer and Mrs. Roth. And meanwhile, we have invited over 30 excellent scientists from all over the world for a research stay here at KIT within this program. And today, I'm very happy to introduce our today's speaker, Dr. Jennifer Pazour, who is Associate Professor of Industrial and Systems Engineering at Rensselaer Polytechnic Institute in New York, and the host institute for materials handling and logistics. And her research area is in the development and use of mathematical models to guide decision-making for logistics and supply chain challenges. And Jennifer Pazour is a holder of many research awards and is also awarding winner teacher, including the Rensselaer Alumni Teaching Award. And we are very honored today to have you here today, Dr. Pazour, at KIT as a so-called International Excellence Fellow. And she is doing her research stay as a part of her collaboration in the scientific area with a group of Professor Kai Fuhrmanns, who has helped us in organizing also in this event, and many thanks to you for that. And now we are very much looking forward to your talk and to hand over to my colleague Kai Fuhrmanns, who will give a short introduction and overview on the academic career of Jennifer Pazour and also on the successful cooperation. And now the floor is yours.
So I'm very glad that we have Jennifer and Pazour here. I think we met first time in 2012 in Gardanne in France. There's a biannual conference of material handling research colloquium, which is organized every 2 years, once in the US and once overseas. Usually overseas was Europe. We also had the honor to have it here in 2016. And that's the first time I met her. She's a student of Russ Meller, and Russ Meller is a very distinguished and thought leader in material handling. Unfortunately, he was lost to industry a few years ago, and he is also taking some other people from the field. I'm therefore very glad that Jen has decided to stay in academia. I think she's firmly settled here in academia. And I think she's now and not only because the others left, I think she's really the young and upcoming person. I think she's blushing now, but that's okay. She's the young and upcoming person in material handling. I think she has very original and great ideas. I think that fits very well in the new world of material handling, which has quite a different character than it had 20 years ago. She got the Bachelor of Science from a rather small university, South Dakota School of Mines and Technology, in 2006, and then went to the University of Arkansas. That for most of you is maybe not that notable, but that is where Walmart is located, and the Walton family has sponsored chairs in supply chain. So therefore, in this particular field, that is a great place to be. So University of Arkansas. And she got her master and PhD degree with Russ Meller, who's really a great and also very nice fellow. I think Russ Meller was also always linked to Europe more than Austria, so she spent some time in Austria at our fellows in Graz. Much faster than in Germany, after her PhD in 2011, she got a professor position at the University of Florida or University of Central Florida in Orlando, and in the Department of Industrial engineering and has then 2015 has taken an assistant professor position at Rensselaer Polytechnic Institute. I just learned that RPI is 1 year older, as 1864 as founded as a university than we are. And I have to say, RPI has been a very great place. I think they somehow have been lacking in the last 2 years, but I'm pretty sure that with your help, they will build that up. She's now an associate professor there in the Department of Industrial Engineering. She had several roles there, also administrative, but I'm very proud that she's still doing her research there. And while we have been applying for this International Excellence Fellowship, we also have been applying for a joint research project, and luckily we won both. But we were firmly committed to do something together, and I'm very glad that she's here. And I'm also, the train has, or the path has been led by Georg Fischer, who has organized that, who was a PhD student who, through the KISS grants, had the opportunity to study with her. And I have to say, she knows a lot of things and can do a lot of things that we cannot do. So we profit a lot from your visit here, and we enjoy it a lot. I hope the other way around it's the same, but I don't know. So please welcome Jennifer Ann Pazour and for her talk. And I think she will convince you that she was very worthy to be invited here. And now with all.
Well, thank you. First of all, it's been like fantastic to be here. Just to give kind of a little bit of background, I think most of us know where we are. I'm up in upstate New York, so I always have to preface, I'm about 2 hours north of New York City, but you are all welcome to visit. And yeah, RPI is kind of our claim to fame is we're the oldest polytechnic university in North America. So I think we're 1 year older than KIT. And Troy has a kind of, for the US, a nice downtown. So it's got an older feel conditioned on we're in North America. And I really want to say thank you. I mean, it's been a really wonderful experience. I've learned a lot, and hopefully, yeah, continue learning. In terms of agenda, you know, I was told this is supposed to be kind of multidisciplinary and supposed to give a big, broad kind of view of the world. The people in the audience probably know, you know, just as much or more about kind of omnichannel and the struggles of automating fulfillment, but I'll start kind of broadly. And then I'll talk about my research interests, and like the goal today is to get you excited. I don't think I have any math on any of these slides. That was on purpose. So I'm glad to give you papers to read, discuss them later, but I won't go into too much detail on any of these. To get started, if you're willing, can you go to menti.com if you have a phone? As you're entering in this, there's some questions for you. And, you know, a lot of us, what's exciting to me about this research is this is something all of us experience. So we're all, you know, have done something in terms of omnichannel. So I'm interested in, you know, which of the following services have you used in the last year? We'll let this kind of flow on to here. So I'm seeing people have visited stores, they've done curbside pickup, they've got stuff delivered to their houses, they've maybe, you know, ordered online, returned it to a store. I guess nobody has ordered online from a physical store. Maybe the inventory wasn't there, and then, you know, used research online, but then actually ended up. Okay, so you should hopefully have one more question now that popped up. So thinking about what you clicked, why did you click that? So, you know, why did you decide to go shopping or go to go get it delivered? Was it because it was cheap, because it was fast, or something else? Okay, you wanted to actually, you know, check out the project or products. So really, you guys are experts on omnichannel. Okay, so if you look at the literature, there are people that have studied this. These are the things that usually come up. So people want things fast. They usually don't want to pay a ton for the price to get it shipped to their house, but then they want convenience. And if you've been following kind of the logistics space, there were lots of companies that really bet on the omnichannel wave kind of continuing after the pandemic, and it's being kind of up and down if that really is happening. But I will say there's lots of space for innovation in this space. So, all right, Georg, maybe can I get you? Thank you. So I put this up here because I think one of the reasons material handling and logistics is a cool topic to teach, but also to do research on is it's very easy to connect to people's worlds. Like, you know, students can understand they've done this, and then we can start talking about math and, you know, computer science and things like that, but they have a connection to this. So thank you for participating. So what is omnichannel? So kind of formally, there's a lot of definitions. What I like to think about it is it's a fluid way to shop. So you can do kind of however you want as a customer. It's supposed to be seamless, whether you go shop online, you go to a brick and mortar store, and you know, it's driven by the things you basically put up there. So it's driven by customers' expectation for speed, convenience, product variety, and then the fact that we all have these supercomputers, you know, in our hands, are main reasons for this. How I also like to think about it is you can kind of fill in the blanks here. You can buy it at a store, you can have it fulfilled at a warehouse, you can get it at your home, you can return it to another store or whatever, right? And so some kind of common names for this: click and collect, buy online, pick up in store. Ship from store is the logistics kind of underpinning of this, you know, and things along this way. So from a consumer, this is great. But from a logistics perspective, I mean, there's a lot of combinatorial different ways you could think about having your products delivered. And then our jobs as supply chain and logistics professionals, we have to support now this complexity. Just to give you some figures, these are US based, but what I thought was interesting, and these are from 2020, is it's a huge amount of click and collect. So this would also be, you know, during the pandemic, a lot of people use these services for health reasons, but they were mainly driven by really large retailers, at least in the US in terms of volume. So 7 retailers, you know, Walmart's, the kind of big names, accounted for 64% of them. And then, you know, in terms of grocery, this is growing, but it's, you know, still, you know, at its like 35% numbers. And so there's a lot of excitement, but I want to kind of also put this in perspective. This is a really good graph when you teach bachelor students about why it's important to label your X or Y axis, is that, okay, this is very growing. This is a trend. But if you look at there, the number, if you can see it, is only 17.5%, okay? So online sales, I mean, it's definitely growing, but it's still less than, you know, 17.5%. So that's, I think, a good thing to keep in mind. I am of the belief that we're not just gonna have everything online. There'll be a mix. And the other thing that's interesting, if you're in kind of the startup business spaces, there was a lot of debate. This big jump is COVID. So everyone decided, okay, I'm not willing to go to the store for health reasons. And there were a lot of big bets, at least in the US, about that number, that trend going. And it's still high, but it's not as high as it was. Okay, so that's kind of some background. So we're here in IFL. So what impact does this have on material handling and logistics, right? That's kind of the question I have motivating. And, you know, what I would say is it's really shifted the efforts from us as consumers to the company. So no one pays me to go grocery shopping, but now if I click and collect, the resources need to be found from the store employees. You may have warehouse workers doing that. You may have gig workers like Instacart, or you may have robots, right? Things along that way. But there's the shift of effort from us to, you know, company resources. And so broadly speaking, there are kind of 2 main ways that companies do this. So one is sometimes called store fulfillment. So they literally use the same inventory in stores to fulfill online orders. So this is a picture from Walmart, you know, so people could shop from those shelves and get the products and pick online orders from them. Sometimes it's called ship from store. And then the other side of this is to say, okay, I'm not going to use the inventory in my store. I'm going to do it somewhere else. So whether that's at a distribution center, It may be a dark store, so it's close to, in town, but it's not allowed for other shoppers to come in. And then they have to, somehow transport these orders to people's cars. Broadly speaking, the positives for store fulfillment are kind of the negatives for micro fulfillment or distribution and vice versa. So one of the big reasons store fulfillment happens is you have inventory pooling effect. So I teach a supply chain class, and we talk about how variability, increases the amount of inventory you need. And if you're pooling two sources, you can lower your variability. So you have usually lower inventory costs. It's also closer to the customer. So there's all these stores already existing. And so customers are willing to maybe drive there and pick them up. And if they are doing last mile, then they could, cheaper transportation. And a really big one is they're utilizing existing store infrastructure. So I've had some nice conversations with the grocery stores in my local area. And that is one of the main reasons they're doing this, is they already have this. It's a way to quickly kind of adapt and meet this new customer demand. But the one major problem is it's really quite inefficient to usually do order fulfillment in a store. So stores weren't designed to do order fulfillment. In fact, they usually put the two most popular things, eggs and bread, as far apart as possible so that you actually have long travel distance, which is the opposite of what you would want to do. When you think about designing warehouses, you're trying to minimize that distance, right? And then it's usually, less expensive land. Stores are usually in more expensive places. And then automation, at least currently, it's been easier to automate these micro fulfillment and distribution centers. I'm hoping with some of the innovations happening at IFL that will be easier in other different facilities. But kind of traditionally speaking, the automation had been designed for kind of warehouses, and so that had some advantages. Okay, what I will say is, and I know this is maybe a lot, is to basically say none of those things are working. So this is from 2020 in August. And a key thing is all the kind of stuff is on this, which means it's negative margins, okay? So this is from the US, and the difference between the dots and the blue things are, the dots are if the customer pays $7 for at-home delivery or $4 fee for click and collect. So if you pay those fees and you don't want home delivery, then you're at least positive. But without those fees, you're negative. And so this, I would say, is a lot of the motivation is that omnichannel is a challenge or you could think about it as an opportunity for us as a research field. I also use this in my classes. I think it's a call to action for really cool jobs as well. Like companies are really wrestling with how to do this effectively. Okay, so this is my perspective, is that my perspective is us as consumers, we're not going to change. We want stuff fast, cheap, with convenience. So I don't think this is going to go away. And I don't think businesses will stop playing in both of these markets. So I think they will have an online option. They will have brick and mortar stores. And this omni-channel idea that I can fluidly shop is going to just even get stronger. What I think is an open question is how to do this well, okay? So I think we have these, both the customer and business in this space. I think the supply chain, the logistics, the material handling needs to work to support the things that are being demanded. So, if I was writing a dissertation, this would be like a good motivating question, right? So like what is less understood is how should we design facilities, material handling equipment, operations, businesses that can effectively combine these online and in-store customer streams and create, synergies or efficiencies that benefit the customers, the businesses, and then society kind of more at large. Thinking about congestion and mobility and, getting cars off the road, things along that line. I don't have the answer for all of that, but there's lots of people in this room contributing to this question, I think, in different ways. And, throughout our collaboration, hopefully we'll put a little ding in that question. I will say that's like the beginning of, okay, omnichannel world. My team is working on some of that, and then we're working on broader things. And so I actually thought it would be maybe useful to talk kind of broadly about research interests. And I know some folks are going to Norway and they need to present about some ideas for their contributions for their dissertations. And so I thought, okay, how do you think about a contribution? I'll admit, when I was a PhD student, someone telling me, oh, you have to make a contribution, I found very overwhelming. And I think it's worthwhile to think about what do we mean by that, at least kind of from my view of the research enterprise. So I'm going to talk broadly kind of about that. So yes, I do some stuff in omnichannel retailing. Broadly, I consider myself a modeler. So I'm interested in taking some system, usually it's a logistics or supply chain system, and modeling it. And so that's like taking it and making the abstract form, usually using math, and then using that model to do something, usually to understand maybe a better design, a better operation, to quantify the benefits of things. And I'll give a few examples of how that is. That when I met Mr. Furman, I was doing distribution center design. So my dissertation actually was on A-frame systems. So I don't know if anyone has seen this, but it's like an automated piece picking common in pharmaceutical distribution, and some other kind of order fulfillment technologies. And then I've worked in kind of some more broader spaces, from transportation, some healthcare, but within logistics. So if you've ever been to a pharmacy, that's basically a warehouse. And so there's a lot of similar problems, like order fulfillment problems, actually in pharmacies and healthcare. They have complications of patient safety and a few other things. I had a project basically looking at military ships as distribution centers. So they are like distribution centers, but very tight and in space. So the people that are doing very high density stuff, that's how I got into some of that work, was how can you put things really, really high density and then get things out quicker. And then more recently, I've been kind of interested in what I'm calling resource sharing platforms. These are kind of the Ubers of the world, but I'm interested in doing this in a way that doesn't add more cars to the road, but taps into kind of existing resources. And so I'll talk a little bit about that, primarily starting with Omnichannel. But how do I do that? What I feel like my intellectual contribution is modeling. So, when you think about modeling, you think about airplanes or something like that. What I'm doing is modeling, but using primarily operations research. So integer programming, some queuing, some, Markov decision processes, things along that line. And so what does that mean is we're interested in some sort of system. Usually it's a supply chain or logistics system, and we develop mathematical or computational, getting into a little bit more data-driven representations of these complex systems. And then usually to solve large-scale problems, you've got to kind of create something that you don't just plug into off-the-shelf solvers. So we usually do some algorithms. And then we use those models to get insights into the problem domain. And to me, that's the fun part, is you have a model and then you get to say something about whatever system you're studying. Okay, so this is how I think about research contributions. I think the best journal papers have all of these three. So we first start with some new system or process. That could be a new material handling equipment. It could be a new algorithm or way of thinking. And there's something about that problem you are modeling that no one else has modeled. So that's what I would call a modeling contribution. So I think it's important to think about what are the salient features of whatever you're studying and what has and has not been captured in previous work. So if you're capturing something like multiple input and output points in a system, then you can basically say, okay, that's my modeling contribution, right? No one else has captured that. And then I think, we don't spend enough time on how do I determine what method to select? So if you're, you're modeling congestion is a really big deal, then you probably want something like queuing theory or simulation. If, congestion's maybe not as big a deal, but there are tons and tons of different alternatives, then maybe combinatorial optimization fits, right? And so I think, there's kind of that goes into thinking about modeling. Then we make the models. I like a lot of my stuff is in integer programming, but it's beyond that. And typically, there's some solution approaches. So you may prove something about the optimal solution. You may create some sort of heuristic approach to solve large scale problems. And so those are usually then algorithmic contributions. I can't just plug it into Cplex and see what comes out because it doesn't solve big enough problems. So there's usually some of that goes on. This is the fun part, is you have a model and you basically have a playground. So then you get to try out a bunch of things. And so I think a goal of papers that we write is that if people don't know anything about the math, they could still get something out of our paper. So this is something I learned from Russ Meller, my PhD advisor, is you want the science, not just the engineering. What are the new insights? if you are studying some new system, is there a recommendation that it should be twice as high and as it is long or whatever, right? This is found out through using your model to get at these things. So that's kind of broadly how I think about this. And I think it's useful to think about this because it's, yes, there's new knowledge, new modeling, new solutions, but it's not like inventing a new, I don't know, it's a little bit more easily identifiable maybe as you're going through and identifying your dissertation topic. Okay, so what have we been doing in kind of omni-channel fulfillment? This is a paper that I worked on with Iman Daria, who's at the business school at the University of Alabama. And so to kind of walk through this, okay, we had a new concept for omni-channel store fulfillment. And this new concept was this. It's somewhat simple, but the concept is if I have to fulfill online orders, what do I need to do is in a store. If you look at it, most of the literature, what happens is they try to avoid in-store customers. So they say, okay, I'm going to route like this Walmart guy, I'm going to route them so they don't disrupt the in-store customer. So the key idea here is we're going to not look at in-store customers as a problem. We're going to look at them as an asset. And there are people in this room that know this better than I do, and I'm learning a lot about this at IFL. But one of the things that we are good at, one of the first things like a baby learns is to like reach, identify, this is this object, right? Humans are still better at that than robots. And I think, you know, with KIT's help, we will get there. But like, you know, this is something that humans are really good at. So can we utilize humans to do that part of order fulfillment? Is kind of the key idea. The other reason is, at least in the US, which is very car-centric, these customers have already driven to the store and they are already kind of walking in the aisles anyways to do their own shopping. So you think about tapping into them to help with order fulfillment, there's what's called lower marginal cost. Some of that fixed cost associated with fulfilling the order has already been done because they're going to do their own shopping. Okay, so that's kind of the key idea that we're interested in. And so how would this actually work? So the kind of concept is we are going to deploy in-store customers to do their own shopping and on the side also pick orders, online orders, okay? So in the US, there's a lot of things. I don't know if you have these, like if you go to the grocery store, there's like, when you check out, you give them this barcode and then they give you discounts. And then they also know exactly what you buy and they send you, you know, personalized shopping, you know, coupons, and they use all that. So if I show up to the store and I'm already a member of this, most of them have apps, what it would do is say, hey, would you like to also help fulfill online orders while you're shopping? And you say, yeah, I'm glad to help and I'll be compensated. And so as I'm shopping, I'm also picking some of items for other people. You may say, okay, who's gonna do that? We actually surveyed people, and not everyone would do this, but actually a decent amount of people would do it at least occasionally. And so we with help of actually some undergraduate students, we got about 140 people, kind of different classifications of people that, yeah, I would help occasionally was the biggest, but you know, some would help a lot, and then some were like, no, I wouldn't do that. Okay? So that's the concept. And then going back to, you know, how did this get published? What are their contributions? This is the salient feature. These in-store customers have some advantages, but they also are more complicated. So they're temporary, you know, they just show up when they do, they're harder to predict. They're also quite limited. So another part of our survey was like, how much would you help? And typically they would only help if it's just a little bit, right? They're not going to spend all day there. And then they're also very heterogeneous, meaning they have different shopping baskets. And why that matters is there's a deadline happening, right? So we want our stuff. And so if I have like 2 hours to take and you only have 10 minutes, it's gonna delay when our orders get dropped off. And they also have different, you know, preferences for things. So what was our contribution is we captured these new salient features into our model. And we also made sure there were backup, like dedicated pickers, because typically this probably wouldn't work for everything, but it would be good to augment. And then we developed a method. Very honestly, the method was pretty standard. You know, it wasn't super fancy, but it did the job. And then we used a bunch of data. So this Instacart data that I know some of you guys are working with was used, and we did a bunch of computational experiments modeling a grocery store and showed kind of if someone was interested in this, what could they expect? And a couple findings we found was, it would reduce costs, but you do need some level of dedicated pickers. Otherwise, you're not going to meet your demand commitments, but you should be able to reduce that. So I know that's a quick tour of a problem, but I'm glad to give you the, full paper and talk about it in more detail, but it kind of goes through the different steps of kind of how I approach research problems. Any questions about that? Question, would anyone do this? Like if you are going to the store and we would pay you, some amount of money to say, pick 5 things while you're shopping. Would anybody do it?
I would think if you have, I think if they make you use the store app where you also organize your shopping list, so if that would be actually to do it. So I think I have butter on it and then would say, okay, bring another one. And I think that I would be, but I probably would do is search for some. Usually it's yeast. When my wife asks for yeast, I always get lost in it. So I would probably shop for things which are on my list anyway or close to, but I wouldn't go hunting down stuff where I don't know where it is in the store.
Yeah.
That's but maybe I'm an old man, so
I would say it might be different for demographics. As a young graduate student, I will do some shopping for the customers as well.
Yeah. So I would say to me, the demographics are like college students that need the money and retired people that have the time. Like those are somewhat, probably not a scientific answer, but like those are like high level. But but your comment about how close they are, that's actually one of the kind of cool things about our method is we took in your shopping list and the order and we matched it in a way that was more similar. And so that was one of the decisions that we were using in our method was to try to match more similar orders together so that it doesn't force you to go like, walk way over to another aisle.
And Jen, I think that would be, the thing that we all as customers would wish from stores, if I have my shopping list, if they would give me a picking order, which is, and to make a deal, I would be willing to do it so if they help me optimize the rest.
Yep.
So
it's interesting. We asked that question actually. Would you give us your list if we gave you a route? That was another survey question, and most people said yes. Not everyone is so prepared, so there's also that. But So anyways, it's kind of a fun concept idea. I think there's potential. I've talked to some local grocery stores and they are actually somewhat interested. Usually when I present my research, they're like, you guys are doing way too futuristic things. And so if anyone's interested, I think there's potential here. In terms of next steps, so Georgette should really come up here and present this, but the concept that we wanted to add is now, what if we had cobots? So the idea is we still have in-store shoppers doing the picking, but instead of like putting it in your basket, doing this, we could have cobots, which are common in distribution centers, and we could say, they could be in an aisle and just say, hey, could you help me? So maybe I say, I need, I don't know, toothpaste. Can you help me? And if you click, then, spits out a coupon that gives you some information or some discount. Because again, there would be service deadlines, we'd likely also still have kind of, dedicated pickers, right? And so this is part of Georgette's dissertation, and he's really leading this effort. But what is hard about this is the routing problem of the cobots, and they need to sync with things we don't have control over. So we are syncing with in-store customers, which we can't control. So that's what the kind of difference is in terms of the modeling contribution. There is a lot of literature in routing cobots, but they usually assume the warehouse has control over how to route the people, how to route the cobots. Here we need to make sure we capture the stochastic inter-arrival time. And it's a very time sensitive in the sense that orders need to be returned, so they can't wait there forever. And this is ongoing work. Also, Iman is helping with this. And so, the modeling contribution is combining cobots with in-store customers in a retail environment. He's got a Markov decision process to model this problem. If you know about Markov decision processes, the curse of dimensionality will get you. And so he's also developed some nice heuristic approaches that are able to do this quickly. And then we aren't quite here yet, but we're planning to then use this to get a bunch of insights into, okay, how could you actually do that? So I think, an interesting aspect is why can't we use cobots in retail environments? I think there's, lots of opportunities for this space. So from a kind of more equipment design, I think there's some interesting things as well. And then we have the project that is in collaboration with many of you. And what I think is cool about this project is the previous two were kind of saying, okay, the facility is there, let's optimize the operations. With this project, we're thinking about, no, how can we redesign the technology? So how can we redesign, this is Patty's wonderful design of a picking system, a platform system. It's very, very cool to work on things that are physically being built. So that is a very nice experience personally for me. And then, working with other experts here, Sebastian and Gideon, Georgia, we're looking at how can we then redesign the store. So kind of thinking about having a warehouse and a store in the same facility, what would that look like? And then how should we redesign technology to support that? And so I'm learning a lot by just being here and thinking about this. And another thing I think is cool, even though we have two streams, there's really is this more interaction, and that's helpful because of this fellowship. So thank you, KIT, for physically being here and kind of interacting with that. So it's fun, and I think there's cool projects that are coming out of this. And I do think this is more the future, is we are not necessarily just gonna have the same looking facilities. They're gonna redesign the facilities and the material handling equipment to support kind of this omni-channel perspective. All right, so in terms of other things, if you have an omni-channel store, you usually have supporting distribution centers upstream. This is Khan Umu. He's now a data scientist at Amgen, but his dissertation was looking at on-demand warehousing. So this is something that's really grown quite large in the US. Companies like Flex Walmarts are using them, and the idea is they're almost like Airbnb for warehousing. And so the idea is you can actually make a dynamic distribution network because you can get distribution capability at months at a time, weeks at a time. And so his stuff was more network optimization, but he also tried to answer, and this was in a industry publication, can they help? And the answer is sometimes, but not always, okay? So they're also much, much more expensive, and they have a different model for how we pay for them. So their per unit movement is very high, but they don't have any fixed cost. And so there are certain times when that's useful, but there are certain times when it's not as useful. So I think that's a good answer to every question is it depends. And this is an answer we found in that research. All right, so that is kind of, more the omni-channel stuff. This is, I'm going to give you like a blast of random projects very, very quickly. This I'm putting up here because it's just starting literally this month, and it's collaborations with other folks, some at the University of Arkansas, some other places, but it's our National Science Foundation, and we are looking at how to build urban resilience. And one aspect of this is logistics. So I know your guys' project where you're making deliveries using automated systems and things like that. The idea here is that we basically would have a digital twin of the city, but then, we need to make sure that humans are involved in that resilience. And then this is going to get more complicated because of climate change, and we're gonna have more and more catastrophes. And the reason I'm putting that up here is the grant is really to build an international network. And so potentially we could add IFL or KIT to this collaboration. So the grant from the US National Science Foundation is to really establish very, very different types of people. They're social scientists, engineers, logistics, people together. So this is kicking off actually this month. And some other projects, and I want to be conscious of time. Here's a question I have for you. So here's my other participation question. So if you were looking at this system and you were trying to conserve energy, and so our goal is to minimize the sum of distances between matching every red dot to one and only one green dot. My question to you is, would every red dot get matched to their closest green dot? Yes or no? Why or why not? Any thoughts? So one reason I'll put this up here is I think what's also very cool about my stay is your groups kind of focus on decentralized control. right? And so a lot of the work that I've been doing is more centralized. So you have a kind of central optimization model. And I would make the case, and I don't know, I just found this graph on the internet. So, potentially we'll see if this is like probably for the system to operate the best, the answer would not be true for every dot, right? There would be some dots that have to give a little bit away because the greedy solution is not system optimal. And that oftentimes happens in transportation problems because there's interdependence. What I want is also what somebody else wants. And if I get, not everyone gets their closest neighbor in like the system optimal way. And so that's common, that's good at like optimization models. They're good at capturing that. But one of the things that's interesting is a lot of times these dots are agents and they have a lot of really good information that our system model does not have. And so we would like to kind of work in some space that's not just central optimization, not decentral optimization. And so this is a project that was also funded by the National Science Foundation, really more around last mile delivery. So ride sharing, crowdsourced delivery. And I've had a number of really good researchers on this project. And the concept here is I want to match like crowdsourced drivers with requests. I need to capture this systematic perspective, but I want to give them choices. So I want them to be able to say, I'm going to my kid's soccer match, so I want to pick up this person. Don't tell me to go that way, right? And so the key idea here is actually quite simple, but it's like basically giving the resources some level of choice. So we're giving them like menus of things instead of dictating to them or giving them full decentralized like options. And so the concept's kind of simple, but then this gets complicated because you need a one-to-one match and you want to kind of make sure the system works. And so a lot of this work is bi-level optimization. We have kind of a system perspective, and then we let each of the agents have some choice. And we're trying to figure out what should we offer each of the drivers and how much should those offers be kind of valued. And so why I put this up, even though it's not really in logistics, but like facility logistics, I think it has some interesting discussions with the decentralized, centralized control. So if anyone's interested in kind of chatting more about that, I would love to hear from that. And, I'm kind of the belief that we need both of these kind of systems, right? So like the system side, the demand commitments, meaning people need to be actually, picked up or their requests need to happen. That's what, operations research, systematic algorithms are really good at. Humans are actually really bad at understanding this, interdependency of my decisions that are happening. But oftentimes people have good local information. They may, just prefer something for privacy reasons. They don't want to know it, or they just have different, autonomy that they want to have. And so how can we kind of combine these together? And so I have a project that's actually quite mathematical. And quite basic research at the moment, but the concept is, could we democratize operations research modeling? So the concept here is, I taught an undergraduate course that basically was, here, take a system and let's model it. And these were all really, really good students, and they really struggled when you gave them a blank sheet of paper and said, give me your objective functions, give me your constraints, give me your decision variables. It's a specialized skill. And so could we somehow create a system that instead asks, Mr. Furman, what do you think about this? You give me a piece of information and I kind of algorithmically generate the constraints, and then I show you a solution and you tell me what's wrong with the solution, and then I keep doing this over and over and over. Very honestly, the answer could be, this is not tractable, this doesn't work, but it's fun because it's a basic research. And it's also cool because I have some kind of heavy hitters in math, and then the refinement layer from kind of control systems are also playing a role. So this is a project funded by the Office of Naval Research, but quite basic research at this point as well. Okay, so that's the last thing, other than I also work in nonprofit spaces, which you may say, why are you also working in that? The similar thing here is it's a resource sharing kind of system. So we are building a project with a bunch of nonprofits to share resources. So this is with engineers and social scientists as well. Okay, this is not research-based, but I've enjoyed hearing about people teaching. And so I'm a fan of collaborative offering, teaching materials. And so this is something I started, it's just a box folder. But if you're teaching any classes and you want to share like active learning type things, I'm glad to add you to this repository. So Mark Daskins at the University of Michigan posted a bunch of stuff for like queuing theory and probability and things like that. Most of them are in course, like helping students kind of activities. And so if you're interested, I'm glad to add you. What I would say is, if you get added, I would like you to add some of your material so everyone, could gain. But I think, why do we every semester try to create new things? Could we help each other out? So that's something if you're interested. So that is what I have to say today. I would say I did okay because there was some audience participation. Would like to see some questions, hopefully new ways of thinking, and get you intrigued enough to read. And then, if you're interested, all of the stuff is kind of on my website. Also, during the pandemic, I recorded a bunch of videos and then I posted them on YouTube. So if you teach design and analysis of supply chains, I have a bunch of materials there. It's not the whole semester because of when COVID hit, but it's a lot of them. So, so thank you. I appreciate this time and feedback. So thank you.